So it's a bit difficult to do a webinar on Emacs because I am a little bit afraid that people who use Emacs regularly might find this very boring and obvious, and people who are totally new to Emacs might find this terrifying and might run away forever of ever considering using Emacs. So I made this fairly introductory because the concept of Emacs modes is pretty fundamental to Emacs. However, if you have never used Emacs and if you find that this sounds terrifying, please do not run away. The last thing that I want in this webinar is to make you scared forever of Emacs. I will be giving an introductory course on Emacs. It's twice 2 hours, starting next week on Thursday and then the week after. And if you are interested in Emacs and you leave this webinar feeling confused and scared, do join the course, do take at least the first part of the intro and then decide whether or not Emacs is for you. Don't get spooked. That's really what I don't want. So there are many fabulous text editors out there. I don't want to start a text editor war. People feel very strongly about the tools they use, and Vim is fabulous. It's one of those old school text editors such as Emacs. Now there are some modern text editors out there that are also extremely great, such as VS Code. But Emacs is still, for people who love it, it's just irreplaceable. And it's just, it has this aura of the olden days open source tool, but it's also extremely performant. It used to be bloated and slow, but that's not true anymore because it has really gotten incredibly faster in recent years. It's obviously free and open source. It's endlessly customizable. So if you like something that works perfectly for you right out of the box, yeah, maybe it's not the best tool for you. But if you are someone who likes controlling every single key binding and the appearance of things, the behavior of things, your auto-completion, and you want to integrate Copilot and spell checking and programming language, syntax highlighting, and the whole formatting, and you want to automate your work with some great macros that make it super easy to rename any number of things easily. Great text searching, can run programming languages and shells, endless undo redo, and it's just so fun. I mean, there are many reasons why you might want to use it. Now, I'm not gonna lie, Emacs is not a simple text editor because it is so performant. It has so many capabilities. It can be really daunting, and it doesn't necessarily get better when you're more familiar with it, because the more you learn, the more you realize how fancy it is, and there's never any end to what you can do with it. That said, you don't have to know every single subtlety of Emacs to enjoy it. With some minimum knowledge, you can really make a good use of it. But if you want to push it, you can push it really far. And it's really worth it. So before I jump into the topic of today, which is Emacs modes, again, because this is a fairly introductory topic, I want to introduce quickly a few concepts for people who are really new to the Emacs world. So first of all, the basics. It is written in Emacs Lisp, which is a dialect of the Lisp programming language. Lisp programming language comes in many forms and many dialects, but it's one of those very old languages, high-level programming languages, second only to Fortran in how far back it goes. It started in the 50s. And editing functionality of Emacs are all written in Emacs Lisp, which means that as soon as you have a little basic understanding of the language, you can customize Emacs endlessly. Now, of course, to make it fast, the interpreter and the internals of Emacs are written in C. It's only the editing functionalities that are written in Emacs Lisp. And yes, it is endlessly customizable. And so this dialect of Lisp is a language based on lists, and it has those typical parentheses that are nested. That's one of the hallmark, the really easily identifiable characters of Lisp, all those parentheses. And it's very well documented because it's all free and open source. It's part of the GNU project. The documentation is there, and huge numbers of volunteers over decades have made Emacs more and more performant and richer and richer. And it is still a very active community today. The fact that it's an old text editor doesn't mean that it's gotten behind, far from it. So a little bit about the vocabulary of the display of Emacs itself. So Emacs can run in any number of frames. So the frame is what intuitively you might think of as a window. It's in other softwares, they're called windows. But so this is a frame, and you can have several frames. But let's consider this case where we have one single frame. The vocabulary in Emacs is a little bit different than in other softwares in that a window is only, a frame can have a single window, but it can have, as is the case here, multiple windows. And it's the subset of a frame that contains what is called a buffer. The buffer is where you see the text that you are editing. Like if you open a file in Emacs, for instance, the content of the file will be displayed in the buffer. So buffers can contain the text of a file, but there are other types of buffer. For instance, you can edit in Emacs directories. So there are types of Emacs buffers to see the files and directories, like a whole directory tree on your file system. You can also visualize images, graphs, PDFs. For instance, this buffer here contains an image. It's some graphs performed by Julia. So here we have the Julia script. So that's the content of a file. So in Emacs, a buffer can contain the context of a file that you've written. Here, what we have is a Julia shell. That's a REPL that is running an instance of the Julia language. So this is an active Julia instance running in this buffer here. And here, this is the graph that this code, this running instance has produced. So you can have a buffer with an image. But in an Emacs window, beside the buffer, you also have this little area at the bottom that's called the echo area. And that's where any output written by the Emacs interpreter will appear. So you will get comments, feedback, information. If you run a command in Emacs that requires some kind of output, it will appear down here. And of course, each window has its own echo area. And then, and that's quite relevant for today's topic, there is the mode line. Similarly, each window has its mode line, and everything is customizable. So the colors, the style, it's all customizable. But you could tell from this image that the current buffer, the one that was selected, so the one that would receive the input from my keyboard if I were to type something, was the Julia REPL, because the mode line was in a different color. But again, I customize the color by default. Those colors are different. So the mode line has a number of information. It's really customizable, but amongst other things, it gives some info about the enabled modes in the current buffer, hence the name mode line. So let's have a little look. So this is my version of Emacs with all of my customization. So if you launch Emacs on your site, it's going to look different, but this is just to demonstrate live what I showed in those little diagrams. So in here, in the center, like the main part, that's the buffer. It contains the content of a file, which is actually my .emacs file, which is also called the init file. It's the configuration file for Emacs. So you can see at the bottom the echo area that gave me some little information. So, okay, for instance, the last thing that Emacs ran under the hood is the cleaning of recent files, and that's why I have this little output here. And then the meltdown here. Okay. Now, a little word about key bindings, just so that the way I have written things in these slides makes sense. People keep making fun, and rightly so, of Emacs about the key bindings, because by default, they're absolutely insane. And some people like the default key bindings, but they're just crazy. They're very lengthy. They require, there's always the joke about the pin key problem, because there's all this Control-C, Control-X. It's a lot of gymnastics. But because you can customize everything, you can rebind them, and you can turn them into something actually very smooth. And my key bindings, I've developed my own system, which doesn't require to have 25 very agile fingers or be a pianist to be able to use Emacs. Now, so what matters for the rest of these slides is the notation, so that you understand what's written easily. It's a very standard notation, probably nothing new for a lot of you, but just to clarify things. So CC means press the Control key and the letter C at the same time. You can see they're pressed at the same time because there's a little hyphen in between. Now, if you see CC space M, that means that you press Control and C at the same time, release them, and then the M key. And Emacs by default, again, has a lot of those series of key bindings, but you can simplify this thing. MX or M with something else means press the Alt key if you're on Windows, or the Option key if you're on macOS, with whatever is hyphenated together. It's called M because, again, Emacs got started a long time ago, and there used to be in the old computers of the day a key called the meta key that has actually now disappeared. When people talk about a meta key in modern computers, that's actually something different. Yeah, as I said, you can have series of key bindings. So this would mean CC, Control C at the same time, and then Control X at the same time, and then M. So that's the way to understand those notations. And you can evaluate Emacs Lisp code when you are in some Emacs Lisp buffer, but except for configuring things, you probably don't need to do that most of the time. But one way to execute commands very conveniently, and that is incredibly convenient to interact with Emacs and access some of the functionality, accept some functions, run all sorts of commands, is to run MX, so Alt X or Option X. And what this will do is that the bottom of the Windows, which typically has the echo area, which is the place where outputs are printed, will be replaced by what is called the mini buffer, which is actually an input area where you can type in things and input information to Emacs. And so if you run MX, that opens the mini buffer, then you can type in some command, and it will run the command. Now, commands that you use all the time, you will use the key bindings to access them, because it's a lot simpler to run your usual key bindings than having to type the name of the command all the time. But if there is something that doesn't have a key binding, or you don't remember the name of the key binding, or some function that you don't run often, this is something that you want to use. So for instance, count words is one command. So it's a function that comes with Emacs that will output number of lines, sentence, etc. So if I run, so here you have my echo area down over here. If I run Emacs up, you can see that now it is turned into some kind of input area. So that's a mini buffer. By default, it will not expand with a bunch of suggestions. It will stay at the bottom. But because I have all sorts of fancy packages that are running to make my Emacs experience a lot nicer, it looks different than it would by default. So now I can type in what I want. So for instance, count words is the command that I want to demo here. So if I press enter, you can see that now in the echo area, I have the output. So this currently open buffer has 18,258 words, etc. Okay. So now with that, we can start talking about the topic of the day, which is Emacs mode. So there are two types of modes in Emacs. There are major modes and minor modes. So the major mode, you can think of it as really the main configuration for Emacs for any type of buffer. Because Emacs is so nice and fancy, it will behave differently if you open, for instance, a Python script or a Julia script or a Bash shell or the Julia REPL, the Julia shell, or if you want to edit directories and files, because each language has its own syntax highlighting, its own formatting. There are all sorts of commands that will be available for Python that make no sense for the directory editor. So various files containing Emacs Lisp code will be evaluated and loaded for different types of buffers that you will be editing. And the major mode sets the main configuration. So there is only one major mode active at any one time. And if you open a Python script, the major mode will be Python mode. If you open a Markdown document, it will be Markdown mode. And you cannot turn off a major mode because there's always one major mode that is active at any time. But what you can do is to switch to a different major mode. So Emacs is smart enough that if you open a file that has a .py extension, it will automatically open a Python mode because it can see that it's a Python script, obviously. But you can manually switch to any mode you want, again, by this Emacs that opens a mini buffer and then running a command with the name of the mode you want to run. You can set which type of file which will open which major mode in your init file. So for instance, .py by default will launch Python mode, but if you wanted the .py file to launch some exotic whatever mode, that is super easy to configure. You can also have some comments at the top of a file that tell Emacs to open a type of mode or another. So there are many ways to go about it. And like here, because this is my init file, so it's written in Emacs Lisp, the Emacs Lisp mode is active. I'll show you in a bit how to test that. But I can, if I want, turn this into a Python mode. So now, of course, the syntax highlighting is all messed up because this is a mismatch mode, but nothing prevents me from doing it. And so all of a sudden, the commands accessible and all the functionality are different. But of course, that's not what I want. Okay. Now, if you open a text that doesn't have any extension, doesn't have any clue as to what mode is suitable for it, the most basic lambda vanilla mode that Emacs uses by default is called fundamental mode. And so, for instance, if I open a new file, so it's a file that doesn't exist, that I'm creating right now, I'm calling it test, no file extension. In Linux, and I'm running Linux, you can create files without file extension or with multiple file extension. There's no rules in Linux for that sort of stuff. So in Windows, you would run into a problem here. But here, because this file has nothing, well, you can see it here in the mode line. Emacs has opened it in fundamental mode. So that's a mode with basic functionality, if you want. Well, here, this is a markdown file. You can see that there is a markdown major mode in the mode line over here. And my .emacs file, you can see over here that it was in Lisp or Emacs Lisp mode. Now you can change this default behavior because, again, in Emacs, you can do anything you want. And so if you would rather that the default mode be, for instance, a text mode, well, you can change that in your init file very easily. That's no problem. But I think fundamental mode as a default mode is, I guess, fairly reasonable. And then there are the minor modes. So the major mode, there's only one, and you can't switch it out enough because each buffer will have a mode. Minor modes, you can think of them as additional functionalities, optional features that can be turned on or off. And so some of them are compatible with any major mode. For instance, spell checking is a minor mode, and you can turn spell checking on or off in any mode. In some modes, for instance, in some programming modes, maybe you don't want it, and so you can set your Emacs so that spell checking doesn't run when you write Python script. But in human language type of major modes, such as text mode or org mode or markdown mode, maybe you want that on. So you can set spell checking to run only in some types of mode. But spell checking is one mode that you can turn on or off in any mode. Other types of minor mode can be auto-completion, auto-indentation, some fancy undo behavior, some parenthesis matching highlighting, or auto-closing of parentheses. Like, for instance, you might want to have matching parentheses highlighted in fancy colors when you are programming, but if you are writing some human language in a text mode, you probably don't want your parentheses to be bright yellow or something. So some minor modes make more sense in some mode than other. And some minor modes actually can only run in particular major modes because they were specifically written to only make sense in a particular context. For instance, some minor modes were written to check the Python formatting and have it match the blackened package, for instance. Well, the blackened minor mode obviously cannot be turned on if you're not in the Python major mode. And because those minor modes can be turned on or off, the Emacs and then the name of that mode will switch them on or off. So for instance, spell checking can be done amongst other options with a mode called fly spell mode. That's the one that I am using. So right now it is on, and I'll show you again in a bit how to do that, but I can by, fly spell mode, I can, so here I can type the whole thing, fly spell mode, but as you can see here, I can also just highlight the proper command without having to type it all. So if I run fly spell mode, you can now see that I have disabled it in the current buffer. I can, by rerunning this, enable it again. So for instance, here I have this word version. Well, I can make a typo, and here this little underlining over here shows me that there is a spelling mistake, and I can I'm blanking. I don't remember all of a sudden because I'm under pressure how to correct it. It will come back in a sec. But anyway, if I don't want to have my spell checker on, I can turn it off, and you can see that the little highlighting has disappeared. Okay. Now, each mode also comes with many commands because when a mode is launched, all of the code that was written for this mode is evaluated, and so you have a lot of commands specific to that particular mode that become available. And the consult package, which is really a fantastic package, has many extremely useful functions for just everything, but it has this consult mode command that makes it very easy to see what commands are available within each mode. So, so I have a little key binding for this mode command. And so if I want to see, for instance, the local minor commands, so those are all of the commands that are available for the minor modes that are enabled in my buffer. If I want to have only the global, I can do this. And so you can see that depending on what type of mode we're looking at in this big menu, we have different list of commands. And for instance, here again, in this buffer, the major mode was Emacs list mode. And in this section here, under major Emacs list mode, you can see all of the commands that can be run and that comes from this major mode. And obviously, any number of minor modes can be active at the same time because they just add functionality to the major mode. So now, I've mentioned several times that I was having this or that mode enabled, I was in this or that mode. So how do you know about all that? So by default, the default Emacs way to check that is the command describe mode. So you can run it with doing the usual MX describe mode, or it's also associated with the key binding F1M or also CHM. So if I run F1M, this opens what's called a help buffer. So you can see that the major mode of this type of buffer. It's the help mode. You can see down here. And so that tells me that the major mode is a Lisp. It gives me a link to the source code of the major mode. And so if I want to visit this file, I can totally, this automatically opens the source code in which the Lisp mode is defined. And I can see the, I can look at the source code for Lisp. It also has the various key bindings for this mode, and it lists every single minor mode that is enabled with some information as to what the mode does, how to turn it on or off, and links to the help file for that particular mode. And those help files will in turn have links to the source code so that you can visit the source code of the files that set those minor modes. If you want to just have information about the major mode, so describe mode will give everything, the minor modes and the major modes, but you can also run F1V. So F1V runs the command describe variable and then major mode. So if I do F1V, that describes variable, and then I can type major mode, and that opens the help file just for the major mode, which was the Emacs Lisp mode in this case. So instead of doing F1V, which is describe variable, I can of course do Emacs describe variable, and then I'm in the same place, and then major mode. Just to show you that those key bindings, all they do is that they run some commands that you can also always access by running Emacs and then the name of the command. If you want just a list of minor modes, you can look at the variable minor mode list. This is just a simpler output. Just give the list of all of the minor modes that are active in a buffer. And you can see there are a lot of minor modes active in this buffer I was showing you. So there's a lot of stuff running. Some of it, some of it has been set automatically by Emacs. Emacs by default associate the major mode Emacs Lisp with some minor modes, but some of them I have set myself to add functionality. Some of them come from Emacs packages that I have installed. And so, as you can see, there's really a long list of minor modes. There's no downside to having a lot of minor modes running. Emacs has gotten very fast, so that's not a problem. Now, again, I mentioned the package consult before. I really love it, particularly in combination with the Vertigo package, which is the one that allows to have this nice interface here with this expanding mini buffer. And there is a command, consult minor mode menu, that makes the list of all of the minor modes and a way to turn them on and off super easy. So I have a key binding for it, but I could also, of course, type Emacs and then the command name. And now you can see that I have all of the potential minor modes. And so I can type the name of a mode, for instance, fly spell. And you can see that fly spell is off because I disabled it. And if I press enter here, I have enabled fly spell mode. So if I take fly spell again, you can see that now it is on. And I can look at the minor modes that are off. So that will filter the ones that are off. And so I can turn them on if I want. I can filter the ones that are on. I can look at the ones that are local, the ones that are global. So this is just a very convenient way that Consult brings to looking at the list of minor modes that are available, the ones that are enabled, disabled, and turning them on. As I said, the mode line gives some information about mode, but it's a bit limited. For instance, here, so okay, we can see down here that the major mode is Emacs list, and those are all these things, some minor modes, but you could see my list was the longest. So they don't all show up here, and you can customize the mode line to show which minor mode should be displayed or not, and with what symbol. And so it's useful to for a number of things that you want to turn on and off often. For instance, flight spell mode is associated with a little S /. So if you look at my mode line here, it doesn't show any S /. But if I turn flight spell mode again, now you can see it is over here. Over here. So if I want to be able to visually quickly see whether flight spell mode is enabled or not, I can add it to my mode line, and then I can right away, without having to run any command, see, oh yeah, flight spell mode is enabled. Now, as I mentioned earlier, you might want some modes to be turned on automatically when other modes are turned on. So for this, there are what are called hooks. Hooks are run at the very end of the source code that loads some particular mode. And hooks can be added to major modes or even minor modes. A minor mode can automatically turn on other minor modes. And for instance, if I want to have the blacken minor mode automatically turned on whenever I launch the Python major mode, I can have a hook. Or here, for instance, there is a minor mode aggressive indent that strictly indents code blocks. I can have it turned on automatically whenever I launch R, which will run the major mode ESS R with this command. Or if you use package, which is a really cool way to lazily load all of your Emacs packages to make Emacs incredibly more efficient. The syntax would look like this. And use package is, by the way, such a great package that is so well built, so well maintained, and has grown so much in popularity that it has become part of Emacs in recent versions of Emacs. So it is now available by default. You don't even have to install it. So I've already mentioned that you can access the source code of modes by clicking on the link that appear on the help buffers that you can display by either describing the variable of a mode or describing the mode. And that is very useful if you want to customize a mode. If there is a function in a particular mode that you don't like, or if you want to change the key binding of something, or if you want to understand some particular mode and change it to match your preferences or your work better, that can be very useful. And for many modes, showing the mode map will give you a quick access to the link. And so, for instance, if
I want to look at the source code of the text mode, which is the mode for basic .txt files, I can run describe variable, text mode map, and then I have a link to the text mode .el for Emacs Lisp. And here I have the Emacs Lisp source file for the text mode, and so I can read it easily. So that's very convenient. And so because everything is customizable in Emacs, you can obviously customize modes. And to do that, you can create a .emacs file. So that's your init file, and then add your own Emacs Lisp code in it. But if you aren't ready to do that, you can also use the easy customization interface. So one really easy way to customize Emacs, particularly at first, is to just run the function customize, either group or face. Face is the appearance. That's to set like the font size, the font type, the color for this or that, the variable that's going to customize any number of variables, and the group is going to be a whole group of variables linked usually with a mode. So for instance, if I run customize group and then markdown, this is going to open this interface where I have any number of functions and variables that I can modify in a GUI type fashion. And I can toggle things on and off, change the functions of things, and then I can change them either for the current session or for future session. And so that's an easy way to customize Emacs. You can also do it, as I said, for a particular variable. So for instance, I don't know, PM face up. So this opens just the one entry for one specific variable instead of the whole group it belongs to, and I can modify this. And by default, you can change that, of course, but by default, those customization will be added at the beginning of your init file. So all of these lines were automatically added by the easy customization. So these are the faces. So this is all the appearance of various things. And then below that, these are my own customization. So it is totally okay to have a mix of things that you customize with the interface, they're going to appear at the top, and things that you customize yourself. There's no problem about having a mixture of approach. Now, something that you have to be careful about is the evaluation order, because things can be overwritten. The way things are evaluated within a file is from top to bottom. So for instance, if you define a key binding twice for different commands in your init file, at first, the evaluation will set the key binding to be attached to command X, and then later in the file, it's going to be attached to command Y. It's command Y that will be in effect for your current Emacs session because it comes after in the evaluation order, so it will overwrite what comes first. So that's very straightforward, obviously. What is less straightforward is that when you are running Emacs, it's not just your init file, of course, that is evaluated. It is all of the Emacs code that gets evaluated at the launch of Emacs, and then a lot of other files that get evaluated when you turn specific modes on or off. Because you don't want to evaluate a ton of stuff at the beginning, because even though Emacs is now very fast, it's just an unnecessary
computer load and loss of time to evaluate, for instance, all of the code to run Python if you just want to open Emacs to write some emails. So you want to try to do some lazy loading as much as possible and evaluate the code for particular modes, so usually particular packages, only when you need them. But that means that things can be overwritten. For instance, a classic situation is that in, say, Python mode, there is a function and you don't like the behavior very much. You would like to write a custom function. So you've looked at the source code, you've seen the function, you're like, yeah, I'm just going to write it a little bit better for me. And so in your init file, you have that version of the function. Now, when you launch Emacs, your version of the function is evaluated, fine. But then once you launch Python afterwards, the default function that comes with Python will overwrite your version because of this evaluation order. So of course, one horrible way to go about that would be to evaluate all of the Python source code each time you launch Emacs, but that's just not the way to go about it because it's just not efficient. So there are strategies for that. One way to go about it is to use eval after load, and you put that in your init file, but whatever comes after will only be evaluated after the loading of some particular package or mode or something. So for instance, if for the markdown mode, there is one command that is markdown demote. It allows to change the header from, say, a level 2 to a level 3. If I don't like its behavior and I want to write my own function, define is the Emacs list way to define a function, I can write eval after load markdown, define markdown denote, blah, blah. And that means that when I run when I launch a new session of Emacs, these code blocks will not be evaluated when the init file is evaluated. It will only be evaluated after the markdown.el file will have been evaluated. And that allows to have my function overwrite the default function rather than the other way around. This eval after load is also convenient when, for instance, you want to customize a function that depends on some variables that are defined in the source code of a particular mode, and you don't want to have all of the source code loaded right away. This eval after load allows to only define your function after the source code of that mode has been evaluated, and so those variables have been defined, and then there is no problem. Without this, Emacs would complain upon evaluating your init file that the variables haven't been defined because you are using in that function some variables that you haven't defined above. So this eval after load is tremendously convenient. And again, if you use package, that great package that is now part of Emacs and is fantastic to like really pinpoint the lazy loading of packages. It comes with some keyword symbols, init and config, that ensure that whatever the chunk that comes after those symbols is evaluated either before, if you use init, or after, if you use config, the loading of a particular package or mode. And so this is really super convenient to know when to evaluate what. Because, for instance, if I want to have a key bindings that will turn, I don't know, some fancy debugging mode, I want to make sure that this key binding is evaluated at the start, because otherwise it's not going to take effect. So I'm going to put it after init. But then if I customize that, some functions of that debugging mode and I want those to be evaluated only after the loading of that mode, I'm going to put them after config. So this is really a nice way to bypass any of the evaluation order difficulties. You don't have to get into that level of subtleties if you just want something simple that works. This is really if you want to have something that's that really starts super fast, if you want to optimize lazy evaluation, if you want to have your Emacs maximally optimized. This is fairly advanced, and you don't have to worry about it right away. But the eval after load, that's something that you'll have to learn if you want to customize your modes. Of course, you can customize the key bindings of modes as you can customize the global key bindings. So a global key binding is a key binding that will work in any mode. And so, for instance, I have a little macro. So global set key, and then like here you can put something, for instance, CCM, and then la la la. So that means that anytime, anywhere, no matter what mode I'm in, the key binding CCM will run the function TTT. Okay, but there's only so many key bindings, even with all those CCCM, CCTT, etc., or whatever key binding system you make up. There's only so many keys on the keyboard, and so it is very convenient to have some key bindings only active in some specific modes. And so those are set in some key maps. Modes, amongst other things, have most of the time, almost all modes have a certain key map. And so when you are in a certain mode, you have some key bindings that get activated just in that mode. And that makes sense because in a mode, you have all these commands that only exist in that particular mode. And so to write key bindings for a certain key map, you have to use a different command, which is different key, for instance, org mode map key, and then I have cc, la. So now this means that I wanted to write the same key as before. So if I evaluate this and then launch org mode, now CCM will run lala in org mode. So if I still have what I wrote before, that's fine. When I am not in org mode, CCM will use the global definition, and so CCM outside of org mode will run TTT, but within org mode it will run the command lala. So here, even though I'm using the same command, that is totally fine. And of course, in say Python mode map, I can have yet another command here. So now the same key binding in if I'm in a Python major mode will now run this command. Obviously, these TT, lala, and CCC are not commands. I mean, obviously, right? To state the obvious. It's just to show you how things work. And so one of the things that you might want to customize when you customize your key bindings are the key maps in this fashion. Or if you use package, there is this bind keyword symbol that allows to modify the key map. But again, you can see the key map appears here. And so just before we finish, because we have 2 minutes left, one last thing that I want to mention is that I did say that you can only ever have one major mode active at any one time, and that is true. And initially, what was also true is that in a particular buffer, you could only ever have one major mode. But Polymode, which is a great package, allows to actually have snippets of any major mode embedded into another major mode. So it still means that at any one time, there is only one major mode that is active, and it depends where your cursor is. For instance, I have this file here. So this is a Quarto file, but Quarto is the successor of R Markdown, but it works with Python and Julia as well. So it's a Markdown document with code blocks that can be evaluated. So here I have some sections of the code. This is Markdown. This is the typical Markdown with a, here I have 2-level header, here I have 3-level header. So when my cursor is here, you can see down in the mode line that I am in Markdown mode. But I have some Julia code blocks inserted in it. And so if I move my cursor here up, you can see that suddenly the major mode has switched to Julia. And so when my cursor is here, the syntax highlighting, the key map that's activated, the comments I have access to are the Markdown ones, but as soon as I move here, it's Julia. So there is only one major mode active at any one time, but this document has different major modes in different sections thanks to polymode. And so this can then be rendered by Quarto into this website where the Markdown sections will be rendered into Markdown. So for instance, the little stars means italic, so this will turn into italic. The Julia code will be formatted into proper Julia with proper highlighting, and the code will even be evaluated. And even though I don't have any result in my source code, this will be evaluated and print the output. So Quarto is a great tool, but even if you don't use Quarto, there are many reasons why you might want to use polymode. I can use it with R Markdown, with R Babel, with any number of things. I really pray that I did not scare anybody. If you are utterly confused and you think this is way too complicated for you, no, absolutely not. Do join the course. You can register for it following the link. If you are at a Canadian university, if you're joining us from abroad, or you're not a Canadian researcher or student, unfortunately, we can't take you in the course, but the course will still be posted on my website, so you can still look at it at your own pace and still make use of it. So the content is like really available to anyone anywhere.